The next type of predictive model is clustering. Clustering type of predictive models. Now, what are these types? Now, clustering models are used to group data points together based on similarities in their input variables. Okay, so if you have data sets which are having some kind which has got data which is so you can do some segregation in your data set. Okay, and based on that you can create some outputs. Sorry. So the goal of clustering model is to identify patterns and relationships within the data that are not immediately apparent. Okay, and group similar data points into clusters. So what you would do is you will do some pre-work, okay, and identify similar type of data and put it together into different clusters or different types of buckets. You will create, suppose there are your data set is having some data which you can probably do some segregation on, and you can create 2 buckets or 3 buckets or whatever. Okay, and when you have created some segregation on based on the similarity of that data into clusters, you can basically process that particular type of data and see what kind of behavior it is showing. Clustering models are typically used for customer segmentation, market research, and image segmentation to group data such as customer behavior, market trends, and image pixels. So what are the common algorithms that we use in clustering model? K-means clustering is a popular method that partitions the data into K clusters based on the distances between the data points. Okay. Hierarchical clustering creates a tree-like structure of nested clusters based on the distances between data points. Density-based clustering groups data points based on their density in a particular area. I'll try to give you some examples, to simplify and help you understand things better. But today we just go through what are the different types of predictive models. Now the fifth one is the time series. Time series models are used to analyze and forecast data that varies over time. Okay, so there is a continuity based on the x-axis as time as such, kind of, as you can see here in the graphical representation, the x-axis is time or the date. Okay, it's years are mentioned on the x-axis. Okay, and price is mentioned on the y-axis. Okay, so time series models are used in a wide variety of fields, such as including financial analytics, economics, and weather forecasting to predict outcomes such as stock prices, GDP growth, and temperatures. So these are the applicable areas where we usually use the time series. So if we are looking at based on the progression of time, what is the output, the behavior of the output, then you usually use the time series. And the common model algorithms for time series type of predictive models one is ARIMA. It is also called as auto-regressive integrated moving average algorithm. Use previous values of a time series to predict future values, taking into account factors such as seasonality, trends, and predict future values, and are particularly useful for short-term forecasting. Seasonal decomposition algorithms decompose the time series into seasonal trend, and residual components, then use those components to make predictions. Then the sixth one is decision tree. Decision tree models use tree-like structure, as you can see on the picture right side. Okay. Uh, the tree consists of nodes that are represented by decision points, with branches representing the possible outcomes or consequences of each decision that is made. Then each node corresponds to a predictor variable, and each branch corresponds to a possible value of that variable. So suppose you are looking at the weather of a particular day. Okay, you see here, you are basically doing a decision based on how the weather looks like. One is that you have it as a rainy day. Okay, then if there is a lot of overcast sky, the clouds are there, and there's large amount of humidity, then you classify it here. Okay, and if the day is sunny, then you further classify it as whether it is a windy day, or the winds are weak, or winds are strong. Okay, and then if so, so these are variables which you have, which basic against which you can assign the values get assigned. If it is a rainy day, whether the day is rainy day, or whether it is raining or not, you can say whether it is yes or no. If the humidity is high or normal, you can say yes or no. If it is windy, and if the winds are weak or strong, you can say yes or no. If there are strong winds, you say yes, and the weak winds against the weak wind, you say no. Right? In humidity, you can say the humidity is high. So high, if it is high, you say yes, or otherwise you say no here. But for normal, you would say then yes. Right? So this is basically a very logical way of making decisions, right? As you can see here, clearly very, very logical. So the model uses the tree structure to determine the most likely outcome for a given set of predictor variable values. Decision tree models can be used for both classification and regression techniques. In a classification tree, the target variable is categorical, while a regression tree, the target variable is continuous. You get it, right? So in a classification tree, the target variable is categorical, while in a regression tree, the target variable is continuous. Give me a moment, please. Yeah. So decision tree models are easy to interpret and visualize, making them useful for understanding the relationships between predictor variables and the target variables. However, they can be prone to overfitting and may not perform as well as other predictive model techniques. We'll talk about what is overfitting and what is underfitting in our machine learning algorithms. Okay, it is related with machine learning algorithms, and it is. I will discuss that. Now, what are the common decision tree model algorithms? One is the CART, classification regression tree, can be used for both classification and regression tasks. It uses Gini impurity as a measure of the quality of a split, aiming to minimize it. CART constructs binary. So it is a little, difficult for you to understand right now, because it's just, we are mentioning about the types of algorithms, but then we will have to get into the details of what kind of algorithms these are. Okay, then you would be able to understand. But This is the common list of algorithms for decision tree types of predictive models is, as you can see on your screen. So then you have the ensemble type of predictive model. Ensemble models combine multiple models to improve their predictive accuracy and stability. So it is a combination of other models as well. Okay, by combining multiple models, the errors and biases of individual models are usually reduced. Okay, so if there is something which is not very good in the other types of models, so that basically the disadvantage of using those models get reduced if you use the ensemble techniques of predictive model. Ensemble models can be used for both classification and regression tasks and are well suited for data mining. They are often used in machine learning or AI competitions and real world applications where high predictive accuracy is required. Okay, so many a times when you are using in the AI space, the artificial intelligence, and you are looking at real world applications, you would probably be using the ensemble predictive models because they give you higher accuracy. Okay. What are the different types of algorithms? As you can see here, uh, I don't know how it is looking at your screen. Give me a moment. I'll try to see if we can enlarge this for you. It's not. So it's the this I'll put it in a new slide altogether then. Okay, I'll show it to you. Now, in the ensemble types of predictive models, you have these algorithms. One is the bagging. Bagging, bootstrap aggregating involves creating multiple versions of the same prediction model on different subsets of the training data and then aggregating their predictions to make a final prediction. Bagging is used to reduce the variance of a single model and improve its stability. We have studied this before as well in one of the modules. And then you have the boosting. Boosting involves creating multiple weak models sequentially, where each model tries to correct the errors of the previous model. Boosting is used to reduce the bias of a single model and improve its accuracy. I hope this is simpler to understand, right? Then you have stacking. Stacking involves training multiple models and using their predictions as input to a meta model, which then finally makes the final prediction. Stacking is used to combine the strengths of multiple models and achieve better performance. Then you have random forest. Random forest is an extension of bagging that uses decision trees as the base models. Random forest creates multiple decision trees on different subsets of training data and then aggregates their predictions to make the final prediction. Okay. Now, for data for basically usage perspective, which are the areas where these predictive type models are used. This particular slide shows that the areas of applications are the domains are finance, healthcare, retail, and e-commerce, transportation and logistics, manufacturing, marketing, and advertising. I'll be sharing these slides with you today so that you can go through them by yourself. applications of data prediction in different domains. Then some of the other domains are energy and utilities, government and public sector, sports, security. So many applications or the domains are there in which these predictive types of models are being used today. And there could be many more as well. So if you look at finance side, so forecasting future cash flow. Every business needs to keep periodic financial records, and predictive analytics can play a big role in forecasting the future health of the organization. So this is again, a place where we are trying to share you an example which is related to predictive model type. So using historical data from previous financial statements as well as data from the broader industry, we will be able to project sales, revenue, and expenses to craft a picture of the future and make decisions because it will give you an insight of the data, and the data will give you some insight, and you know all of the historical data, and then you can make some decisions based on that, right? So this is a kind of an example for forecasting future cash flow. No matter the field in which we work, there is always a great amount of uncertainty involved in this process. Okay. So, but we are trying to reduce, what we try to do is we try to reduce the uncertainties, okay, with predictive model types. But again, the predictive models have to be very properly used because we should be knowing which predictive model we should be using on which kind of data. And the quality of the data is also very important because the data should be relevant. Otherwise, you would not be able to get the correct insight, right? And the decisions that we make on an incorrect data will lead to incorrect decisions. So we have to be very, very careful when we are doing this kind of work. So entertainment and hospitality, determining staffing needs. Now, if you have to determine the staffing needs, one example explored in business analytics is casino and hotel operator Caesars Entertainment's use of predictive analytics. So many places, they are using the in the entertainment industry and the hospitality industry, they have to determine the staffing needs. So for determining those staffing needs, they are employing the predictive model techniques. In entertainment and hospitality, customer influx and outflux depend on various factors, all of which play into how many staff members a venue or a hotel needs at a given time. Okay, overstaffing costs money and understanding could result in a bad customer experience. So if there is understaffing, then you would not, so there would not be people to attend the customers and it would result in bad customer experience. So these predictive models basically help you how we can manage our staffing needs in the hospital industry or in the something like entertainment industry or hospitality industry. If we are understaffed, it creates bad customer experience because what we get is overworked employees, and and then they tend to make costly mistakes. So we have to be careful. And then for say probably if you're looking at a hotel and you have customers, there is a footfall of customers and we have not planned for, we have not done some planning around the staffing needs. We will be in a problem because we will not be able to give good support or customer satisfaction to the people who are coming here there in the hotel to stay. So to predict the number of sorry to predict the number of hotel check-ins on a given day, a team developed a multiple regression model that considered several factors. This model enables Caesars to staff its hotel and casinos and avoid overstaffing to the best of its ability. So you have to look at the trends, right? What is the footfall? How many how many customers are you expecting, and at what time, and in what days, and which time of the year. So based on that, you need to plan, right? Give me a moment. Then you have marketing. Marketing is about behavioral targeting. In marketing, consumer data is abundant and leveraged to create content, advertisements, and strategies to better reach potential customers where they are by examining historical, behavioral, and using it to predict what will happen in the future. We engage in predictive analytics. Okay, so in marketing also, how we use we use the consumer data, and we leverage the consumer data to create the content, advertisements, and strategies to better reach the potential customers. So additionally, historical behavioral data can help we predict a lead to develop leads, likelihood of moving down the funnel from awareness to purchase. For instance, you could use a single linear regression model to determine that the number of content offerings a lead engages uh, with predicts with statistically significant level of certainty the likelihood of converting to a customer down the line. With this knowledge, you can plan targeted advertisements at various points in the customer's life cycle, right? So these are some examples of how we use predictive model types. Uh, Preventing malfunction in manufacturing. So we can be better prepared uh, if we use the predictive techniques, so that we have the algorithms that support us to using the historical data to accurately predict when a piece of machinery is likely to malfunction. Okay. When the criteria for an oncoming malfunction are met, the algorithm is triggered to alert an employee who can stop the machine and potentially save the company thousands. So suppose the machine is going through some kind of a stress of overuse, okay, or it needs some kind of attention, you will get to know based on the data, okay, or that what you have, and your predictive model would indicate you that this is the time that you need to take attention, attend the your machine and get it into probably less load, or possibly if it needs to be serviced or it requires a regular routine service or something, you need to down the machine, and so that we have to prevent the machine going uh, machine outage as such. So this analysis predicts malfunction scenarios in a moment rather than months or years in advance. Okay. So some algorithms even recommend fixes and optimizations to avoid malfunctions and improve efficiency, saving time, money, and effort. This is an example of prescriptive analytics. More often than not, one or more types of analytics are used in tandem to solve a problem. So there are multiple ways that the predictive models can be employed based on the data, based on the type of work that we are doing, and we need to see how we have to use it. So one, we have to plan it. Now, it is being used in healthcare also, like early detection of allergic reactions. Another example of algorithms for rapid predictive analytics for prevention comes from the healthcare industry. There is a WYSS Institute of Harvard University partnered with Keep Smiling for Abby foundation to develop a wearable piece of technology that predicts an anaphylactic allergic reaction and automatically administers life-saving epinephrine. So this is a drug actually. So, and what is anaphylactic allergic? It's basically very what you call as dangerous kind of a thing. So you need to be, if such kind of allergic reactions are likely to happen, you can use the predictive model techniques to avoid such situations. So the sensor called ABSense detects early physiological signs of anaphylaxis as predictors of an ensuing reaction, and it does so far quicker than a human can. So it's very quick and you are better prepared. When a reaction is predicted to occur, an algorithmic response is triggered. The algorithm can predict the reaction severity, alert the individual and caregivers, and automatically inject the epinephrine drug as such when necessary. The technology's ability to predict the reaction at a faster speed than manual detection basically could save many lives. So healthcare industry also, you have usage. Then you have data exploration and visual techniques. Okay. Introduction to data exploration. We have discussed data exploration in the previous modules also, and we'll look at it in more detail here as well. So data exploration is a critical initial step in the data analysis process that involves understanding, visualizing, and summarizing the data to gain insights and identify patterns. So you have studied in exploratory data analysis, right? EDA. So those techniques we have already done in the previous modules. But again, they would fall as a part of our study in data prediction and decision making. Okay, so what is data exploration? Data exploration is the initial step in data analysis where you dive into a data set to get a feel of for what it contains. It is like detective work for your data, where you uncover its characteristics, patterns, and potential problems. Now, why is it important? Data exploration plays a crucial role in data analysis because it helps uncover hidden gems within the data. Through this initial investigation, we can start to identify patterns and trends. Are there recurring themes or relationships between different data points? Anomalies. Are there any data points that fall outside the expected range, potentially indicating errors or outliers? So,
Excuse me, sir.
yeah, madam. Yeah.
Sir, meeting will end in 5 minutes, sir.
Okay. We have basically done, almost done for the day.
Okay, sir.
Okay. Yeah. Let me. Remaining meeting is 9 minutes, I see. It's still 10 minutes are there.
No, sir. It will take time to convert. No, sir. It is showing the time.
Oh, it is showing that time as well, is it?
Yeah, sir.
Okay. No problem.
Okay, sir.
Okay. Uh, so data collection, how data exploration works. So what are the different steps in data exploration? One is the data collection. We know that we have to collect the data first, right? That's the foremost thing. Data exploration commences with collecting data from diverse sources, such as databases, APIs, or through web scraping techniques. This phase emphasizes recognizing data formats, structures, and interrelationships. Comprehensive data profiling is conducted to grasp fundamental statistics, distributions, and ranges of the acquired data. Then the next step would be data cleaning. We have already studied this before as well. Integral to this process is the rectification of outliers, inconsistent data points, and addressing missing values, and all of that work we do in data cleaning, right? Data cleaning, data refining. This step involves employing methodologies like standardizing data formats, identifying outliers, and inputting, missing values. Data organization and transformation further streamline data for analysis and interpretation. Then once you are ready with the data, it's good clean data. What you do, you use the exploratory data analysis. Now, this EDA phase involves the application of various statistical tools such as box plots, scatter plots, histograms, and distribution plots, for which you use Python. Okay, we know how to go about it. We will look at it in the coming slides as well. So additional correlation matrices and descriptive statistics are utilized to uncover links, patterns, and trends within the data. Then you do feature engineering. What is feature engineering? Feature engineering focuses on enhancing the prediction models by introducing or modifying the features. Techniques like data normalization, scaling, encoding, and creating new variables are applied. This step ensures that features are relevant and consistent with the type of data. Okay. Model building and validation. During this stage, preliminary models are developed to test hypotheses and predictions. Regression classification or clustering techniques are employed based on the problem at hand. Cross-validation methods are used to assess model performance and generalizability. So steps involved, data understanding, data cleaning. I think we can stop here for today and resume tomorrow to take it further. Okay. How much time is left? It's showing here 5 minutes. The steps involved in data exploration. Data exploration is an iterative process, but generally some key steps involved. The first step is to understand the data. So we have to familiarize with the data, get an overview of the data format, size, and source. Then variable identification, understand the meaning and purpose of each variable in the data set. Then data cleaning, identifying the missing values, locate and address missing data points strategically, removal, imputation, and we have studied all this before. Error correction, find and rectify any inconsistencies or errors within the data. Outlier treatment. All these techniques we have already discussed before in the previous modules. So then we have exploratory data analysis where we look at the univariate analysis and the bivariate analysis. So univariate is basically analyze individual variables to understand their distribution. For example, histograms, box plots for numerical variables, frequency tables for categorical variables. Then bivariate, explore relationships between two variables using techniques like scatter plots to identify potential correlations. Then you have data visualization, creating visualizations, use charts and graphs and all those things. So choosing the right chart, we need to be aware as to which chart has to be used for which type of visualization. Tomorrow we will look at that and we'll have a graphical picture which basically will tell you as to which graph is to be used when. Okay, so that we will have a look at. Select visualizations that best suit the type of data and the insights you are looking for, choosing the right chart. Iteration and refinement. As you explore, you may need to revisit previous steps. So sometimes you may have to go through some iterations, okay, and do some refinements again and again over the same set of data. New discoveries might prompt you to clean further, analyze differently, or create new visualizations. So once you're working with the data, we may have to keep working on the data and refine that data, so that the more we refine that data, it will give you more insights, right? So it's an iterative process. You keep refining it cycle by cycle. So today it might show something else, but when you rework on that data, it might show you some more insights tomorrow. So that is what we mean by iteration and refinement. So these are the advantages of data exploration here. We will discuss them tomorrow. Let's close for today, and I'll stop sharing here. Thank you so much for your presence in the class today. I would highly request that if others can join, they will also benefit. And so that is pretty much for today from my side. Okay, Ananya, you can stop the recording. Okay, friends, good night and bye-bye. Let's close it for today. We'll meet tomorrow. Thank you so much for being here. A better attendance would help everyone. Thank you.
Thank you, sir.
Thank you. Thank you. Yeah, you can stop.